All right, welcome to solving quadratic equations by using the quadratic formula. Woohoo! Sometimes when you solve quadratic equations, you can't factor them. So we have to have another way. Now, you can use the calculator, but you also can do this algebraically. First thing you have to remember is that when you're reducing square roots, because if you look at the quadratic formula down here, this is the quadratic formula. Here we go. Woo! Yeah, the quadratic formula has big radical in it. So this big radical, you need to know how to use. Now, I know you've done this before, and you have reduced radicals before. But just as a little refresher, let's go over it. Now, perfect squares are any value times itself. So, the number perfect squares are 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc. But then you also have x squared. Then you have 2x plus 3, that's an x, plus 3 squared. These are all perfect squares, as long as it's any value times itself. So 36 is a perfect square. So the square root of 36, now you can put that in your calculator if you want, because that's a nice perfect rational number, or 6. The square root of 25, same deal. The square root of 25. 25 is a perfect square. And it is 5 times 5, so that makes the square root of 25 5. Now, if you get to something like 500, you're like, oh no, it's not a perfect square, the number is crazy, I can't figure it out. So, what we do is we break it up into two separate factors, where this one is a perfect square, and this one is the factors that are left over. The leftovers. So 500 has a perfect square in it. It has a lot of perfect squares in it, but we actually want the biggest. So the biggest perfect square that goes into 500 is 100. And 100 times 5 is 500. So that's two factors that multiply to 500. So 100 is a perfect square, and the square root of 100 is 10. So it's 10 times radical 5 is 500, the square root of 500 reduced. Then we look over here at the square root of 30, and we try to break it up into perfect squares, and we drive ourselves crazy, because you can't. There's no perfect square that goes into 30, so we can't be done. Then we look over here at 72, and there is a perfect square that goes into 72. There's lots. You could try this on your own. You could pause it and see. But what you want to do, or the easiest route to take when you're trying to find perfect squares, is list the perfect squares out, like we have done partially up here. Okay? What you want to do is find 72. If this was a number line, let's do this way. If this was a number line, and we had to reduce 72, we would look on the number line and try to find the biggest perfect square that goes into 72. So if 72 was here, the next perfect square closest to it is 64. And we would just type in our calculator, 72 divided by 64. Oop, I don't even know what that is. 72 divided by 64, and see if it divides evenly. It doesn't. It's impossible. So then we go to the next one down. So that was 8 times 8, so 7 times 7 is 49. Does 49 go into 72? No, it does not. So then we try 36. Oh my goodness, 36 works. Yay! And it is 36 times 2. And that works. If you go the other way and you start down here and you look at 4 and then 9 and those, You're going to find perfect squares that divide evenly, but it's not going to be totally reduced, and it's a lot more work. So the square root of 36 is 6, so the answer here is 6 radical 2. Then we work our way down, and we're like, okay, now let's check out the cool quadratic formula. Okay, lucky for you, this quadratic formula is actually given to you. You do not have to memorize it. But there is a song to help you memorize it, and I'm going to just do it anyway. So if you know Pop Goes the Weasel, it goes along with Pop Goes the Weasel. So if you can't recognize the song I'm singing, that's what it is. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I will never do that again. Okay? Now the big deal about that is there's a few things. There's this plus or minus, and then there's the all over 2a. Now it's everything on the top divided by the 2a. So you have to be careful of that when you're doing this. So that plus or minus means that there are actually two answers, because you know whenever you solve a quadratic, you're going to get two answers. Not necessarily real answers, but you always get two answers, and this quadratic formula will give you those. Now, this plus or minus is simply shorthand to say, okay, there's negative b plus this radical over 2a, and negative b minus that radical all over 2a. And we'll go through that when we do each of these problems. So I know you've seen this before, but, you know, who knows? So you have to solve this quadratic formula. You have to solve this equation using the quadratic formula. The first thing is you do have to get it in, oh, you didn't see that. You do have to get this in this right here's format. So you have to get 0 equals and this mess so we can figure out what A, B, and C is. It has to be in this order, descending order, and the 0 needs to be first. So that's important to know. So if you look here, it is in descending order. It does go x squared, x, and then the number. Unfortunately, this 1 is on the wrong side of the equal sign. So we need to subtract the 1, bring it over to the other side, or simply change its sign. And then we can find our A, our B, and our C. And it's as simply as the order that they're in. So A, B, C. The sign goes with it, so take it. So 2 is your A, B is negative 4, C negative 1. Okay, and then we have, since C is negative 1, we take the quadratic formula. I am awesome at this. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. And then we plug it in. We simply take the negative 4 and put it in its spot here. So B, everywhere there's a B, I put a negative 4. Okay? I can do this. Now, wherever there's an A, I put the 2. And wherever there's a C, I put a negative 1. Not an A, I put a negative 1. Okay, so there we go. So now all we have to do is do the math for each one of these pieces. So we just figure out right here. First of all, this, a negative of a negative 4, positive 4. Then here we have to figure out what negative 4 squared minus 4 times 2 times negative 1 is. Okay, if you had issues with sign numbers, if you had issues with getting answers right with these things, please don't. Just plug all this right here into your calculator right now, and it will do it all for you. Okay? Take a second, pause it, put this into your calculator right now. Got it? Okay, you should have gotten 24. If you didn't, talk to us, talk to one of your teachers, make sure you know how to do it soon. Okay, so all you're doing is plugging that in. Then what I like to do is take this radical 24 and just take it off to the side and reduce it like we did up at the top. Find a perfect square that goes into 24. Start high. So the highest perfect square that goes into 24 is 16. Okay, it doesn't go in. Then try 9. Then try 4. 4 goes in. 4 is the perfect square. 4 times 6 is 24. So the square root of 4 is 2. So right there, right where this 24 is, I don't write that. I write 2 radical 6 over 4. And that's the answer. Now it's not fully simplified, so let's fully simplify it. What you need to do, and this is very important, is you need to notice that there's 1, 2, 3 outside numbers. Everything outside the radical. If everything outside the radical is divisible by a number, then you can divide it. If even one of these numbers is not divisible by, in this case, 2, then don't do it. Okay? So here, 4 is divisible by 2, 2 is divisible by 2, and 4 is divisible by 2. So we simply write this as 2 plus or minus radical 6 over 2. Now that plus or minus is come back to haunt us here. All right, so the final answer is simply x equals 2 plus radical 6 over 2, and x equals 2 minus radical 6 over 2. So all this work that we did with this plus or minus was simply a shorthand way so that we didn't have to do this problem twice, one with the plus and one with the minus, because it's going to be the same in the end anyway. Question. Find the exact values. Now I'm just going to do a few examples. They all, are basically the same thing, just over and over. Got to get everything to one side. So remember, we want to have a positive x squared term. We want to have a positive leading coefficient. So 2x squared is bigger than x squared, so I'm going to move everything to that side. Okay? I hate that. So I'm going to subtract my x squared. I'm going to subtract my 4x. Subtract my 4. Then this whole side is just 0. And I just do the math here, so this becomes x squared minus 6x, minus 3. I thought that was a 1. So there we go. So now it says we have to use the quadratic formula, so I don't even have to bother trying to factor because I have to use the quadratic formula. You simply figure out your A, your B, and your C. Remember, they're in order. So the number in front of that x squared is 1. Never, ever, ever, ever put a letter in there. It's always just numbers. They go right in order. -1, -6, -3, done. Plug everything into that quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, just simply do the math for each of those pieces, reduce, and you're done. So negative a -6 is a 6. These two ones are easy. Simply plug this whole thing right in the calculator. Okay, now remember that was a minus sign. My handwriting is kind of went bad there. That is a minus sign, so plug that in. Take 1 second. Pause. Make sure you can get that number because that's the most important number right there. It's actually got its own name called the discriminant. It's pretty exciting. So get that number right and life will be better. All right, you're back. Did you get 48? Did you? I hope so. I did. Okay, so then we take that 48 to the side. We see if we can reduce it. I just don't like to do it in the equation over there because it gets very messy. And I'm generally not a neat person, so that's why. So 48 can be broken down. Be careful here. 16 and 3. So that's 4 radical 3. 48 you see a lot, so just get used to it. The perfect square is 16. So it's plus or minus 4 radical 3 over 2. So then each one of these is divisible by 2, so I can do it. Remember, if one of them wasn't, you couldn't. So 6 divided by 2, 4 divided by 2, and 2 divided by 2. And then we can simply write it as 3 plus or minus 2 radical 3 and over 1. Don't need to put it, but you can if you love it. So you can put that over 1, or I can't erase like that, or you don't have to. All right? My dog is whining, so I apologize. I can't stop him. Now, as you notice for this particular one, I didn't break it up into 2 pieces. Not really necessary, but it's good to know that you can do it if you do it. Alrighty. So this one, again, they say use the quadratic formula. So I think I can factor this one, but I don't care. You can't do it. Don't. You have to use the quadratic formula. It's telling you to, so do it. It's already set up, set equal to 0 in descending order. So I just go right to A equals 1, B equals 16, C equals negative 57. That's right. And we simply plug it in. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's a 1. Okay? Now these numbers are good. Alright, those are easy. That stays negative 16. And we simply have to figure out what that number under the radical is. Pause it now. Do it yourself. See if you can figure it out. Make sure you can get that number yourself. Okay, I'm sure many of you that did pause it are saying, Miss Barris, are you crazy? Or you're saying, I got to be wrong because I got 484. Well, you're not wrong. 484 is right. No big deal. It's a big number. But the first thing you always should do when you have a big number, the first thing you should always do is see if it's a perfect square. And if you put 484 into the calculator, lo and behold, perfect square. Square root of 484 is 22. So it's negative 16 plus or minus 22, because 484 is simply 22, the square root of 484, and we divide by 2. Alrighty, so this, more can happen here. So let's do the more that can happen. What we have to do is this problem could have been factored because we are going to get a nice rational number. But sometimes this happens. You got to do it. So what we have to do is break it up into 2 roots. It's x equals negative 16 plus 22 over 2, and x equals 16 minus 22 over 2, or negative 16 minus 22 over 2. And you simply have to do the math. Remember, do the whole top, so negative 16 plus 22, which would give you, what, 6? Yes. Positive 6 divided by 2, so x is just 3. And this one is negative 16 minus 22, so that's negative 38, and negative 38 over 2 is negative 19. So those are your 2 answers. It's not radicals, but you still had to use the quadratic formula. Now this one down here, the final one, just throwing up, changing things up a little. You're going to get a radical answer, but, oh, it did say use the quadratic formula. All right, so you have to use the quadratic formula, but you can also use factoring. So with this one, you can actually take out a GCF. Okay, we T-chart, and we can say, okay, one of the roots is 0, but one of the roots is this equation here. Now this one would be really easy if I just did this. Add 8 to both sides, take the square root, and x would be plus or minus the square root of 8. And if I even went crazy and wanted to reduce it, x is equal to, I can move this, 2 radical, plus or minus 2 radical 2 after the radical 8 is reduced with a radical 4 and a radical 2. Okay? But it said I have to use the quadratic formula. People, I tell you. So we have to use the quadratic formula, but we only have to use it for x squared minus 8. So we simply let a equal 1, b is 0 because there is no x term, and the c is negative 8. Remember, the b is the one that always has the x on it. So it doesn't have, there's not one with an x on it, so it doesn't exist. So it's 0. And we use that, and we plug that into the quadratic formula. So negative 0, okay, whatever that means, plus or minus the square root of 0 squared minus 4a, I got this, a c, all over 2a. So all we have to do is figure out, no, negative 0 is just 0. There's no negative 0. So plus or minus the square root of that gigantor mess there, which is 32 over 2. So then we simply have to reduce that 32. Again, I'm going to take that over to the side here because I'm just a mess in general. So, oh, not 36, 32. Okay, and then it's 16 and 2, so it's 4 radical 2. So this is 0 plus or minus 4 radical 2 over 2, all over 2. Now, 0 into 2 is just 0, and at this point, we don't need the 0 anymore, because 0 divided by 2 is just 0, so that's gone. So then it's plus or minus. We can divide the outsides. Remember, when you're dividing, it's only the outsides of the radicals that can divide, or the insides. So outsides, 4 divided by 2 is 2. So it's 2 radical 2, which is what we got over there. Okay, this much easier method over here, but if you have to use the quadratic formula, remember, b was 0. And you got to plug it in, do the reducing, and do the math. Have a great day.